All right, welcome to the first orbit question from this assessment, right? And then let's see, we're given the period and we want to know the planet's mass, right? So since we're given the period, we have to use this orbital expression, right? The force of gravity, right? Planet's mass, satellite mass, right? Is equal to the centripetal force. So m 4 pi squared r over t squared. 4 pi squared r over t squared, there it is, right? Satellite mass cancels, and we're solving for m, so I'm going to cross multiply. So gm t squared equals 4 pi squared r to the third. There we go. And then we're solving for the mass, so the mass is going to be 4 pi squared r to the third over g t squared, right? Highly recommend that you do the math, so cross multiply, right? Cross multiply, right? This times this is this times this, right? Then divide, and then sometimes you have to take like a square root or something like that. Okay, so this guy, we're solving for the mass. Let's just plug those numbers in. So 4 pi squared times 7.8 times 10 to the 6th, and that's to the third, right? Divided by 6.67 e minus 11. And then our period is 2.3 times 10 to the fourth. Oops. E and times 10 to the mean the same thing, right? And then that is squared. Okay. Now I'm going to type this in. Remember that the denominator needs to be in parentheses, or you need to actually use the alpha F1 if you have the new TI-84 with the new OS. You can actually do this fraction. Remember that this denominator, I'm going to flatten this expression. So I'm going to go 4 times pi squared, don't forget to square pi, right, times 7.8 second comma, or E6, right, raised to the third. Gotta go forward arrow, and then I go divided by, and then I'm starting my denominator, left parenthesis, 6.67 e negative 11 times 2.3 e4, right, 2.3 e4 squared, right parenthesis to end my denominator, okay? And I'm getting that the mass is 5.3096 times 10 to the 23rd kilograms. I am successful. Okay. Every assessment is going to have one with period in it. It's also going to have one with velocity, right? So this is what you do if there's period. You use the centripetal acceleration. That's just acceleration, right? Okay. Use the one with the period in it. If they give you velocity or need the velocity, do the one with the velocity in it. Okay. That would be v squared over r, right? Okay. In general, the orbital situation is gm m over r squared is equal to the satellite mass times the centripetal acceleration. That could be v squared over r. That could be 4 pi squared r over t squared, right? That's a 4. Okay, one or the other, just v squared over r. There we are. It could be either one of those, okay?